Well, welcome everyone. Today's session is about the cross-domain interoperability framework, which is one of the projects in the CoData WorldFair activity. Arafan will fill you in on the details when we get to that. But what we're working on is a set of guidelines and conventions for how to really implement FAIR principles in a cross-domain environment. So not just the sort of highfalutin, nice stuff, but actually try to make some concrete, actionable recommendations about, okay, here's what we can do to actually make this happen. So Arafan Gregory, who's with CoData, will do an initial presentation, providing an overview of the CDIF activity. CDIF is Cross-Domain Interoperability Framework. You'll probably see that acronym appearing various times. I'll do a short presentation about the discovery work group package that's parts of this. There's various components of the framework. The discovery is the simplest one, and we've been working on that. And so far, I think we've made the most progress there. We actually have a draft set of recommendations. I'll talk briefly about that. Doug Fills will then talk about the aspects of discovery on how we're recommending to use web architecture following patterns that have been pretty successful in the Ocean Information System and the NSF Science on Schema.org, I mean, geocodes activity and some other things that are going on. And then finally, Pierre Ligi is going to do a talk briefly about convergence between these different activities, which to this point have kind of been working in parallel, but really with very similar goals. And the question is what kind of stewardship framework might we be thinking about, and what role could ESIP play in that? So that's the goal. So there'll be 4 presentations, try to keep them to 10 or 12 minutes each, and then followed by discussion on the various issues about, what do people think about where we could go in the ESIP framework with merging these frameworks and recommendations. Right now, the CDIF recommendations are to use schema.org vocabulary for the implementation. Is that sufficient? Should we be thinking about other recommended implementations, for instance, using DCAT or some other metadata scheme that's widely adopted? And then are the content models sufficient? Are there other things we need to account for? And one of the big topics that we've been talking about is, well, API-based distributions for data sets, service-based data distribution, access to sensitive information. So how do you deal with personally identifiable information data where that becomes sensitive data becomes a big issue? So those are the conversation items we were thinking about to pursue at the end. And that's the overview and agenda. I haven't seen Arafan yet. I'm going to stop sharing here for a minute and see if he emailed me back. Nope, nothing yet.
I also haven't seen anything, Steve.
He says it won't let me log in.
To Kiko chat? Why don't
Yeah.
I could work on that with Megan and see if we could help him out there. Could you we probably have his email through registration. So if someone else wants to go first, we could help try to get him in.
I'll start my presentation, and Annie, I'm going to send you his email in the chat here.
Okay, great.
And I'll just go ahead, and then we'll move forward into what would have been the second presentation about the discovery framework. So within this cross-domain interoperability framework, the discovery aspect is really focused on providing documentation for the resources that we're interested in finding on the web, and not just data sets, but ontologies, vocabularies, software, all the kinds of things that people need for doing their research and any kind of science-based activity. But the focus, at least initially, has been on things that are delivered in files. So there was a brief mention of API-based delivery.
Steve, I made it here.
You're here.
Yes. So
Excellent.
before you launch into this, if you want me to,
All right, we'll go back to the beginning. Sorry about that. Okay, can you see the screen, Arifan?
I think I can. Yeah.
Should
Do
say
I? Should,
I can switch the slides at this point. That might be the quickest thing.
okay. Should I just screen share my own slides, or how do you want to do this?
Oh, if you're ready to screen share, why don't you go ahead? You should be able to.
If it'll let me do.
You should be able to, Arifan, you're a co-host.
Okay. There. Can you see the? Let me put it in presentation mode. Is that? Does that work?
Got it. Yep,
Okay.
we're good. Super.
All right. So I guess I'm here to give you a little bit of background on WorldFair and CDIF, the cross-domain interoperability framework. And I think Steve was starting to explain this to people. My name's Aravan Gregory. I'm giving this presentation on behalf of myself and Simon Hodson. We're with CoData. I don't know how much background, Steve, you've given people on this, but
A little bit.
okay, because CoData is really the leading this project, but it involves a lot of people, some of whom will be also presenting today. So I wanted to talk a little bit about making data work, which is a decadal program that CoData is leading on behalf of the International Science Council. CoData is the data arm of the International Science Council. And a big part of their direction these days is really on what they call mission science, which is looking at the cross-domain grand challenges. Now, these are things like climate change, infectious disease, disaster risk reduction, areas that are all inherently cross-domain when it comes to doing the science that can inform good policy, good societal responses. And this has been a program going on since 2017, basically was when the preparation started. And the biggest piece of it up to this point is WorldFair, which is a project I'll talk a little bit more about. WorldFair is an unusual project because it's a 2-year project that is funded by the European Commission under the Horizon Widera grants. But we got a dispensation to include global partners in the project because the focus of the project is on fair within domains and between and across domains, which means that to really practically address this, it needed to be a global initiative. And you can see from the list of institutions and countries and so on here that it really is global. We have people from places like New Zealand and Kenya and Brazil, as well as the typical American and particularly European partners here. It's a pretty large project, and I'll talk a bit more about that in a minute. But what we did was recruit use cases in a bunch of different domains among organizations that were really looking seriously at fair applications within their domains, and in some cases across domains. A bunch of links here that you may want to follow later. I think the slides will be made available. Here's the obligatory logo slide with all the partners. So we have quite a lot of beneficiaries and partners in this effort. I don't think it quite does justice to the actual membership of the organization, because I'll be talking a lot about CDIF, in which we've also recruited a lot of outside experts as well. So, but these are the organizational partners. When I talk about WorldFair, it's really based on something that came out of the Turning Fair into Reality report, which was a report from the Commission that talked about how do you take these principles and really realize the promise they have in terms of doing better science through better access to data. And one of the key things they recommended there was the development of interoperability frameworks for sharing resources, data, and related metadata within disciplines and between disciplines. And so WorldFair is really exploring that part of the Turning Fair into Reality recommendations. That report came out in 2018. Obviously, it's been a while since then, and it's really only in the past year and a half that WorldFair has been in progress. This is what we call the pedal diagram, and it sort of serves as a logo for the effort. But you can see, if you read the list here, that there's quite a broad spread of domains that we're including in this effort. So everything from cultural heritage through chemistry and nanomaterials, social surveys, population health, biodiversity, ocean science, and on and on. So there's a very, very broad spread of disciplines. And what we found in each of these areas were projects that were focused on FAIR and realizing FAIR within their domain, within that community. And it's not particularly even. I can't say that all of the case studies here are in any sense the same. But the idea here, what FAIR meant to them, what their current practices were, what their intended practices would be. And then in the middle, you see this thing called recommendations on FAIR assessment and FAIR assessment, work package 2. And that work package is focusing on what FAIR means among all of these domains, what they have in common, and how to create a set of FAIR recommendations for exchanging resources between domains. I want to talk just a little bit about what we mean by a domain in that sense, because what you see in FAIR are, yes, sometimes domain communities, sometimes they're infrastructure-focused communities that are themselves a little bit cross-domain. The idea is that when you have a community of practice that has FAIR resources and wants to use resources from outside that community, what do they have to do to be able to easily share those resources, both to and from? And those communities are sometimes more characterized by infrastructures than they are particularly by disciplinary domains in a typical sense. But I think you get the idea. This is a ground-up effort to understand what FAIR really consists of in terms of its implementation and how that can be done in a cross-domain setting. So that's really sort of a quick view of what the WorldFair project has set out to do. I want to step back because I'm going to talk more specifically about the cross-domain interoperability framework, which is that set of recommendations coming out of Work Package 2, that central group in the petal diagram. And I'd like to sort of remind people that FAIR is not only about academic research. It's not an end in itself that makes it easier for academics to conduct cross-domain research, although it is that. The point at the end of the day, from the perspective of WorldFair, from the perspective of CODATA, is that we need better science through improved data access to inform responses to the grand challenges. And I think having lived through COVID, everybody understands the nature of the research you need to deal with those kinds of challenges in an informed way, in an intelligent way. And that's the sort of big motivation here. We need FAIR to help governments create evidence-based policy. And yes, that means some very, very intensive research, cross-domain research. But at the end of the day, there's a real-world driver here. And that means in many ways, we look at FAIR implementation as an engineering exercise and not an academic research field. And not everyone understands FAIR in that way. So I like to remind people of that. I think when you look at implementing FAIR and large-scale reuse of data and resources, you can understand that as a technical challenge using these sort of bullets. There is a huge amount of data in the world, and some people say that that volume of data is growing exponentially. Now, I don't know that that's literally true, but it might be. There is a lot more data in the world than there was even a couple of years ago, and that phenomenon seems to be accelerating. What we do know is that existing manual approaches to documenting that data, to providing the metadata we need to easily exchange that data between systems is failing. That the manual approach to this simply cannot scale to the growth and the amount of data we have to the extent that we already have massive data holdings. And what this leads to is a demand for machine actionability that if you really want to make FAIR work in a practical sense, particularly across domains, we need to harness the power of machines, not just AI, but all kinds of efficiencies that are driven by computers. And you see that theme a lot in discussion of FAIR now, that FAIR is really demands machine actionability. When you follow that logic, though, if you're going to replace manual efforts with machines, as it were, you require a lot of granular and very detailed metadata about the things that you're operating on. And I think in many ways that demands a shift in how we look at data management today. we typically are not thorough enough, precise enough, granular enough in the way that we describe our data to really support easy interchange by machines of those resources, easy processing. What we're trying to do here is to automate the data wrangling that today is a huge proportion of a lot of research projects. Some people say it's 80% of the effort, and really we think it ought to be more like 20%. But in order to automate that 60% in the middle, we need more granular metadata that is precise and sufficient to do the job. The other key thing is it asks for interoperability, and that means that machines have to be able to communicate and interoperate, which means standard ways of describing metadata that are not specific to domains. That might work within a domain FAIR community. It will not work across domains because you need something that makes equal sense to the sender and receiver, as it were, of any given data set or resource. And that means these have to be generic standards in some sense. I want to explore that last theme a little bit because a lot of people who have looked at FAIR and talk about exchanging resources between domains say, oh, we all have standards, so we'll map our domain standards to the other guy's domain standards, and we'll be able to interoperate. Now, that kind of starts to break down when you consider that there are something more than 1,700 recognized standards in like fairsharing.org. And those standards, you multiply sort of the number of standards in any domain by the number of profiles of those standards you could use by the number of target standards they'd have to be mapped against. And you end up with a burden that we cannot support. So mapping alone between standards probably won't get us where we need to go. The idea behind CDIF is that we come up with a generic set of standards that cover some majority functions in FAIR that act as a common tongue so that any given domain can map to and from the sort of generic standard set and be able to communicate at least to a reasonable point in order to support necessary FAIR functions. Now, that said, some things simply are too domain specific to be easily mapped into a generic standard. A lot of domain ontologies fall in that category. I can send you my ontology, but you won't necessarily understand what is meant by that ontology. There are some things that don't require mapping at all because they're effectively universals. Things like units of measure and time and geography are reasonably well standardized now so that two different domains can be expected to use the same expression of that metadata. So there are some exceptions in this picture, but the fundamental idea is to take a many-to-many equation and reduce it to a many-to-one equation to make the problem of mapping between standards more tractable. So what is CDIF exactly? CDIF, the Cross-Domain Interoperability Framework, is a set of guidelines for exposing resources in a machine-actionable way, FAIR resources, for cross-domain and cross-infrastructure use. It's essentially a lingua franca for FAIR, if you want to think of it that way. A set of basic functions for implementing the FAIR principles have been established because you have to agree on the functions you're going to support before you can identify the set of information, the metadata, that you need to support those functions, that is required to be exchanged between parties. Those metadata sets are encoded into profiles of common standards so that they're easy to adopt. Hopefully they're familiar to most communities. This is designed in a way that they're progressive so that simple things are simple, more complicated things are less simple, but that people can choose which kind of functionality they want to do at what level is the basic design idea behind this. And ultimately, we're looking at baking the metadata profiles of these standards into what are effectively implementation cookbooks. So we advocate the use of common technology approaches based on web technology fundamentally, so that implementing this becomes a fairly accessible, easy exercise for people with typical skill sets, if you will. We're not talking about new standards. We're not talking about new technologies. This is an effort to use existing things in a more coordinated way. In order to produce these guidelines, we have all of these 11 use cases in WorldFair that have done what we call FAIR implementation profiles. This is a methodology developed by the Go FAIR Foundation. And it's essentially a little questionnaire that you fill out talking about the current practice within the domain around FAIR. What resources do you use? What standards? What services? and what your future directions are. So we used that as a tool for getting some basic information out of the use cases, and then had more detailed meetings to collect requirements on the ground. While we were doing that, we also recruited a team of 30 experts, some of whom you'll be hearing from, like Steve and Doug, shortly. And half of the experts we recruited went into an advisory group. The other half are in the working group. We meet every 2 weeks, and then in between times to develop the recommendations that will be that first draft of FAIR. And so we tried to get people from standards bodies, from different FAIR initiatives, people who are implementing FAIR in an active way in large scale, that practical experience to bring to the party, as well as these requirements from the domains on the ground. This is a very abbreviated list of the kinds of functional areas we've identified and the kinds of standards that we're looking at. And it's not that there aren't a lot of good domain standards, it's that we were forced to choose standards that were typically W3C standards or somehow independent of domains in particular. Things like schema.org or DCAT. You might be familiar with ODRL for digital rights, SCOS and XCOS, and so on. The technology approaches we use, like I say, are very much web-based ones, web services, JavaScript. JSON-LD has emerged as a really powerful way to bridge the JavaScript world and the RDF world, if you're familiar with that language. Steve will go into more details about this. I'm not going to talk this slide very much, but we're looking at a number of profiles in the initial draft with some dependencies, but with the idea that they're the beginning levels in most of these functional areas, and that we try to make them as standalone as possible. So you're not required to do anything that doesn't have a hard requirement on some metadata that exists in another profile. I don't want to go too far into this because it's a little confusing, but this is an internal diagram we're using to sort of identify dependencies and to guide the work. This is basically my last slide. Steve is going to talk about that public review draft of the discovery profile. So I won't go into that here, but there's the DOI if you need the link. We're going to be doing additional drafts that are similar to that on data integration, data access, controlled vocabularies, and provenance in the coming months. The idea here is to have a first complete draft version by May, which is an output of the first go-round in WorldFair. After that point, we're going to have a second round of WorldFair where we will continue to test and refine, add levels to different profiles, possibly add functional areas, and so on. So even FAIR is right now a project. The cross-domain interoperability framework will live beyond the project and be carried forward first under WorldFair and possibly through some other organizational foundation in future. But the idea is that it is a living body of practice that will be maintained and adjusted as needed. There's my email and Simon's. If you have further questions about this, you can contact us. So with that, Steve, I'm done. So I'm going to turn back to you.
Thanks, Arifan. Tag, I'll pick it up from here. Where's the share screen? There we go. And so I'll be talking more in detail about, not in a lot of detail, but about the discovery framework. And let's see, how can we do that? There we go. So I started a little bit earlier. The focus here, at least initially, to try to keep things tractable, given the timeline we have, is focusing on file-based data. So data that can be delivered as individual packages, not just data, but any kind of information resource, ontology, vocabulary, software, all the things we're interested in. Anything required for research, data analysis, or policy development. We're interested in supporting search applications. So this is for discovery. So part of one of the critical things here is sort of basic text-based information like titles and abstracts. But we also want information about authors, keywords, all that, we're all familiar with the standard Dublin Core metadata. But also we want to support initial assessment of the resource, which involves getting a little bit deeper into the what's in the data, let's say, things about variables, processing methods, workflows, data quality. So that's also on the board. So just as the framework for how we're thinking about these things, we're dealing with all kinds of different resources. And some of those resources are non-digital resources, things that exist in the world. So we're doing one of the projects I'm involved with is how to catalog physical samples. And so these are not things we can send over the wire. We have different kinds of abstract things that we're interested in at the sort of work level, if you're familiar with the librarian thinking about works, abstract things like Mickey Mouse or something. So there's these non-digital things we're interested in. And then there's a lot of stuff in our information system on the computer that we can represent with digital objects. And a digital object is a bit stream that contains some kind of information about that digital object is a resource. For the non-digital things, we have to represent them with a digital object in the information system. And then all of these things, resources have identifiers associated with them that are the computer processable tag that represents that thing. And on the web, identifiers resolve to digital objects. And if the digital object is something that's born digital, there's a lot of things out there like that, then the identifier can resolve directly to that thing. If it's a non-digital resource, the identifier typically has to resolve to a metadata record, something that describes that non-digital resource in an information system kind of way. Born digital things also have metadata records that describe them. So the idea of the metadata record is it's something that's about something else. And the discovery focus is on these metadata records. These are the things that get aggregated, that get collected, that we want to crawl the web and find and be able to index to help people find the stuff they're interested in. So the question is, what's in these metadata records? So our approach here has been nothing unusual. We start by defining, well, what are the information requirements that we need to have in these metadata records? And there are some things that are mandatory. That is, if we don't know it, the metadata record is worthless. There are things that we call required but nillable, which means, well, everything has it, but we might not know it. So for instance, every person has an age, but we might not know what their age is. So that would be, and then there are things that are recommended. Okay, this is really good to have, and you should put it in there, and then optional. So a progression of optionality in that. And then the other aspect of in the recommendation then is, okay, so we have these information requirements. How are we going to implement them so we can serialize them on the web? And we've been using JSON-LD, which is an RDF serialization. So we're resource description framework. And we're using the schema.org vocabulary. And this is largely based on the success of this approach that we've seen in a variety of related projects recently, that adoption has been fairly successful in using this, but there's a lot of variability in how this can be used. So what we're trying to do with the discovery recommendations is, again, as Arifan mentioned, the idea is to come up with a set of conventions that will enable machine interoperability. So the content items we're interested in yellow are the required things. So everything has an identifier, which uniquely identifies it. It has a title, which identifies that thing, that resource for people, and ideally would be unique, but isn't required to be unique. There's a distribution, which is how do you tell people, well, how do I get this thing? That's what distribution is about. There's rights, which are what are the licensing and legal restrictions on what I can do with the resource if I do get it. A metadata profile is basically the format for the metadata record that allows machines to process a metadata description, but if it knows what the profile is, it knows how to process it. And then a resource type, which is a really high level categorization for the kinds of things that you're describing. And then going from that are the required but nillable, and anybody who's worked with metadata for any time will recognize most of these properties. One of the things that we're including in the scheme is the idea of information that's useful for metadata management. So when was the metadata record most recently updated? Who's the responsible party for the metadata content? Is there an identifier for the metadata record as a digital object distinct from the thing it describes? And there's some questions around doing this. People have various approaches to this practice. But these are the content items that are in the recommendation currently. And so the serialization, we're using schema.org with JSON-LD. And this is just a framework of what a metadata record would look like. It starts out with the basic schema.org, the context, which just gives you some shortcuts for making the text that you see in the serialization simpler. There's an identifier, the @ID, for the metadata record. The type says what kind of thing it is. The metadata record is a digital object. It's a digital document. When was the metadata record created? What's the serialization scheme for the metadata? What it's conforming to? So that's this conformance. And then the about section here contains the information about the resource that the metadata is describing. So there's an identifier for the described resource. It has a type. Schema.org has a set of types which are largely oriented towards commercial activity on the web, but dataset is one that gets most commonly used for the resources we're interested in. But as we expand that, having more granular type classification is really useful. So in the detailed schema, which you can see in the recommendation document, there's also, you can have additional types from a vocabulary. It has a name, a description. You can link it back to the metadata record itself. So that's the basic framework for how the schema.org record would be constructed. This is just don't go into detail. The important thing I wanted to talk about in the context here with ESIP is, okay, so we've had the science on schema.org recommendations are out there, and I think they've been pretty successful and seen a lot of adoption. What are the differences or similarities? So for the most part, the CDIF recommendations are very, are match what's in the ESIP science on schema.org recommendations. A couple things. Okay, so what I'm going to go through here in the next couple slides are where are the differences in, between them. So the CDIF recommendations include this information about the metadata record, the profile, the identifier for the metadata, maintainer or contact for the metadata, when the metadata was modified. These things are useful in harvesting systems on the web for people to understand, do I need to update my metadata? I mentioned additional type for more granular resource categorization. And then there's some hard type roles that are defined in schema.org. And so publisher is in here, provider. There are some things like that which we can use the role construct in schema.org to use a more soft type approach for the relationship of responsible parties to the resource, and use different vocabularies for those role relationships. One interesting one is the encoding of geologic time. So the age that a resource is related to. In geoscience, this is particularly interesting, but also in archaeology and a lot of other fields where you're dealing with stuff that happened in the past, and you have data that's relative to some previous event. Right now, the encoding recommended in the CDIF is using time intervals from the OWL time, whereas in SOSO, it uses time instance. And this is a sort of technical difference, but it's one of these little niggling details that gets in the way of interoperability. And Arifan mentioned earlier that really to make this machine actionable, you really have to get pretty granular about the conventions you're using, or else it makes it really difficult for clients to process things in an interoperable way. And so this difference between, is a time interval is time bounded by intervals, or is it bounded by instance? It's a technical thing, but the other detail there is things about geospatial coordinates. So CDIF requires using WGS84 for a spatial reference system. That's a pretty commonly used spatial reference system that works for the whole globe. And CDIF also requires either using point or bounding boxes for spatial extents. But in the science on schema.org recommendations, you can use lines and polygons, and you can also use other spatial coordinate systems. And it has a way of specifying what the spatial reference system is for those coordinates. That gives you a lot more flexibility, but on the other hand, it makes life a lot more difficult for data aggregators, for metadata aggregators, because then they have to figure out how to transform those coordinates into some standard system they can use for spatial searching. CDIF also uses the publishing principles for policies related to maintenance and expected title lives. So this is an additional property that's in the CDIF recommendations that people are using in a lot of the metadata we're seeing, but isn't actually included in the ESIP recommendations. As far as on the ESIP side, we have is accessible for free, and which is just a Boolean that says, can you access? Do you have to pay to get this thing? And also the ability to include something in a data catalog, so you can group data sets together using that. The SOSO also has recommendations about using prov-o relations, and the schema.org is based on, to actually provide more information about provenance. These aren't included right now in the CDIF recommendations. SOSO recommends using a potential action implementation to describe distributions via an API using URL templates. This is a topic of conversation in CDIF right now, but we currently don't have anything like that in the recommendations. And then I mentioned the stuff about spatial extent. So these are pretty small differences, mostly in terms of properties that there are or aren't there, but the differences in terms of how temporal intervals are encoded, how spatial location is encoded, whether roles are related with hard types or soft types. So all of these things are conceptually pretty straightforward, but in the mechanics of interoperability, it's those kind of details that eat up all your time when you're actually trying to write code to harvest metadata. And so having pretty clear conventions about how to do these things makes life a lot easier for people building applications. That's what we're trying to do with these CDIF recommendations. And so this is one place I think where the ESIP discovery group and the science on schema.org and CDIF really can work together to come up with agreement about, okay, what are the conventions we're all going to look at here. So again, here's the link for the draft recommendations. They're on Zenodo. They're also there's a copy of the Adobe Acrobat file, a PDF file, in the attachments for this session. So have a look at those, and we'd love to get comments and feedback and ideas about that. And if anybody has any ideas about the issues I brought up here during our discussion time at the end of this session, I look forward to that. And with that, I'll turn it over to you, Doug.
Great, thanks, Steve. I'll go ahead and share my screen here. All right. Well, thanks, Steve, for setting up the session, and also thanks for everyone for attending it. What I'm going to talk about is a little bit different take on discovery, and I'm talking about the web architectural base to discovery of the resources that I think Steve was really kind of talking about here, right? So this presentation is really talking about how do we locate things on the web, how do we find those indexes so that we can actually begin the process of then operating on those resources. So this is not talking about the details of those resources. I think Steve did a great job of talking about those already. I will only briefly talk about it into the extent that it addresses what I'm meaning by discovery here, which is actually just finding resources on the web. When we really think about this, there's probably an element of this that's very familiar to everyone, or especially data providers and things like that. And that is this kind of classic concept that we think about, which is create a sitemap, right? Have a sitemap.xml file that points to all the resources that are on your system, and perhaps have a robots.txt that provides some guidance in terms of how fast things can be indexed, or other things about that. I'll talk about those in just a second on the next slide. But many of these things we're familiar with, especially because of the popularity of things like Google Dataset Search and things like that, which leverage these types of things in order to find those resources and then index them into that process. So this is kind of classic web architectural discovery, right? Robots.txt points to a sitemap.xml. That might be kind of optional whether you have the robots.txt or not. And then the individual resources that are pointed to by that XML document. When you start talking about a community like Ocean Info Hub or others, some of the work that's being done in Decoder and previously in geocodes, a lot of times these are not crawls of the web, right? These are curated partners that we're working with. And as such, then you may have some mechanism to maintain an index of those sources. Within Ocean Info Hub, this is the Otis catalog. The Otis catalog then is what we're kind of using to hold our partners and the links and the metadata about those partners, including the sitemap on .xml. And then that goes into a configuration file for the actual process of us harvesting those resources. So this is pretty basic, pretty straightforward. And when we look at a typical robots.txt or sitemap.xml, this is really what we're kind of finding. And when you look at that, it's very basic. I think one of the things I just kind of like to highlight is that we can run into issues of implementation with this, right? When we're working with our partners, they have to maintain that sitemap XML. They have to make sure that if resources are created or removed or renamed, that appears in here. If we want to leverage something like the last mod node within the sitemap, then they have to be able to know when that modification has occurred in their data infrastructure and update that sitemap.xml file as well. And sometimes that set of procedures and having that as a policy within an organization can be difficult. And so the question becomes then sometimes, can we actually trust things like last mod? Is it actually reliably getting updated? There are things that we could do with sitemap.xml. It's XML, right? You could add more namespaces to it. We could add properties in there that would address some of those concerns, but you want to be careful doing that in a non-standard manner. There are other types of sitemaps that are out there. I think Google has made some for videos and news and things like that. So it is an extensible system like that. But there can be also issues of scale with these 50,000 records per sitemap. Then you make a sitemap index that points to multiples of those. What happens then is at an implementation level, this can get a little difficult, right? Within the context of Ocean Info Hub, geocodes, decoder, I've had the opportunity to work with people on implementations that read these. And there can be some impedances in terms of utilizing these at scale, and also being able to find change management within there, right? So that we can do indexes that are just looking for the changes that are occurring within an organization. That said, this is a very nice approach, right? It's the classic canonical approach. It's very simple. It's web architectural based. Use the web. It's a great foundation. And if you're an organization that's looking to expose information to a community like Ocean Info Hub or some of those that are in Decoder, Polder, or others, this is a good way to do it. There are some issues or things that are interesting with implementation. So just as a quick aside, and I've got two of these in here. As I was putting these together, I thought, let's be trendy, right? Let's look at things like Hugging Face. Let's look at things like Kaggle, and see what they actually have and what they're actually exposing. And I was really shocked when I hit Hugging Face and said, oh, look, they have a robots.txt. That's fantastic. But yet they have no sitemap. It's 404 on the sitemap. And similar with Kaggle too, right? There is no sitemap available. And I was like, wow, really? These are some groups that are doing a lot with data sets. Why are they not utilizing this approach? I'll revisit this later in part 2 of this, but I was really shocked when I found that. So this is one of the things probably more interesting that has kind of come across my radar, and that's signposting. So if you go to signposting.org, this is a very interesting engineering approach to essentially expressing a topology of resources for these types of things, right? And so this is a mechanism that leverages web architecture and things like, and so there are multiple ways that this can be done. I'm going to focus initially on HTTP link headers because it's the one that's the most interesting to me. but it's a mechanism for leveraging HTTP now to express information about the relationships and the topology of those networks. So rather than leveraging HTML or JSON LD as a document or a resource that we're transmitting over HTTP, this is actually leveraging the protocol itself, the HTTP protocol itself, to represent that information. Now, what's interesting about that is that the primary thing that does is provide great scale. The ability for the system to react quickly is amazing. Tens of thousands of resources and calls that can be done fairly fast. And so, my apologies, I'm going to have to hold this guy over the bar during the presentation. So the thing that was interesting to me about this as well, and I'll talk a little bit about this in just another slide that's coming up, is it addresses certain approaches to indexing APIs as well. Because one of the things that was kind of, well, let me not jump ahead again. In this case, then, and you can see an example of this, you can actually access a resource using HTTP and retrieve information about it represented in that header file. So another element of signposting is this interoperability catalog. And so what this does is this actually utilizes another RFC on the web for well-known addresses. So you may not be familiar with .well-known, ironically, it's probably not that well known, but it's a common namespace within a domain that you can use to represent certain information. Sometimes this is used to exchange security information, contact information, information about PGP encrypting elements, things like that. There's probably 2 or 3 dozen registered URLs with the well-known environment. And this FAIRcat, this FAIR interoperability catalog, is utilizing this, and in particularly, it's utilizing this as a means to represent information about services that your domain may provide. Maybe a Sparkle endpoint, maybe an OGC catalog service, maybe things like this. And what was very interesting for me in this regards then is that this allowed a way to address the integration of APIs along with the data representation. Before I get to that, though, I just want to talk a little bit about this kind of resource inspection. And this kind of touches more on what Steve was talking about. But it is feasible, right, that you could express within, for example, a JSON LD document hosted at a website, information about the relationship between resources and also upper level indexes for those resources as well. You could do this again, as I mentioned, just with the JSON LD. There are other approaches to discovery that exist: Open Graph, RDFA, microformats, the prop find HTTP method. Really, though, these are not super popular implementations, and so the practicality of using them or recommending them is interesting. So just a quick aside again, then the exercise 2, then when I went out to Hugging Face and looked at their individual data sets, surprisingly, they all have JSON LD type data set information there. Fairly decent records as well about that. But it was intriguing to me again, and we could discuss why, but that this is a situation where Hugging Face is not providing a sitemap to these, but just providing the dataset.json. Potentially, this is because their argument is that a group like Google Dataset Search is simply going to come in and crawl their index and make that. And that's fine if you're Google, if you're at a scale where you can do that kind of thing. For communities that are looking like Ocean Info Hub to create their own knowledge graphs, their own environments, it really, you about need that sitemap.xml to guide that, or something like signposting. So one of the things that's always kind of that I've always been wanting to try and address is this issue of APIs. And You know, we can have descriptor documents. We can have, you know, OpenAI Swagger. We can have capabilities documents, all these types of things, REST description documents, things like that. But that doesn't facilitate the discovery of those resources, leveraging web architectural approaches. One of the nice things about FairyCat within the signposting concept is that it actually utilizes this concept of API catalog within that well-known space to provide a mechanism to create a JSON link set of your resources. Again, these can be API, open API type systems. They could be Sparkle endpoints. They could be OGC services, things like that. So this is an interesting way to leverage web architecture to express not only data resources, but potentially services that you express as well. Just a couple slides left. I did want to just bring up a few things that people might be talking about. Obviously, there are things like OGC, what's going on in the OGC space. Yes, there are things like OGC catalogs and things like that. And even things like Stack or Geo API may have some mechanisms for discovery. But these are mostly catalog services, and they don't really provide a means for the discovery of those resources, and in particular, the discovery of the topology that those resources might exist in, right? The ability to hit a singular point and then actually see what's around you, see what's related, whether that's data, services, people, organizations, things like that. Things like nanopubs or linked data fragments are really kind of frameworks for RDF. They don't really, again, address this web-based discovery. Linked data event streams, again, very interesting, but not really addressing this functional use case. And the digital object internet protocol is very cool and does actually address some of this, but I just don't see any activity or uptake with that particular one. If there's ones that I've missed, I'd love to hear about them because I'm really kind of intrigued at the landscape of this environment. And just in conclusion, I would say that there's nothing about signposting that replaces classic robots.txt and sitemaps. They can coexist, and in some ways they can complement each other. One of the things as I was looking at this, I was super intrigued at the possibility that you could very rapidly generate your sitemap based upon the topology expressed by signposting in that environment. So anyway, I probably went a little long, and I'll just go ahead and exit it from there. I think Luigi, I think you're next.
Yeah. And we'll have questions after Pierre's session, so look forward to seeing what people are thinking.
Participants can use the chat too, right? So
Yeah.
they can already warm up some questions there, so that we can think about them. So please be encouraged to do that. So, I'll round off this session with a little bit about how CDIF, SOSO, and others have intersected with the project that Doug mentioned, also that was mentioned a bit earlier by Arifan and Steve, this ODIS, this Ocean Data and Information System, which is a federation of partners around the world that are sharing ocean data under the auspices of the Intergovernmental Oceanographic Commission of UNESCO. So this is a project that started 2020-ish, and it's building up like a functional federation of sharing metadata at this stage, building up a big map of ocean data in service of multiple global aims and decadal strategies. So I'll go into that. It's going to be a little bit of a high-level overview. There's a session tomorrow, and there's another one after tomorrow, which is really focused on ODIS and its intersection with a number of ECIP clusters. So I'll be quite terse here and focus a little bit on how it's interacting with CDIF. So, of course, I can't be that terse. So I'll talk a little bit about some of the background concepts. So yeah, ODIS is building, digital ecosystems are everywhere. They're just interacting systems that are sharing bits and pieces of data, and it could be anything, really. And our goal in ODIS is to, number one, identify and delineate this digital ecosystem for the ocean that's focused on the goals of UNESCO and IOC, and as well as the UN Ocean Decade, and mature that digital ecosystem. So take it from, let's say, opportunistic interactions or transient interactions to a more stable framework, and eventually matured into a data space with integration on demand. So digital ecosystems are socio-technical systems. The socio bit is the hard part. technical bits, we have a number of solutions, many of them work. Getting people to do things in the same way and finding out which recommendation is actually going to work for all of your stakeholders is a different question, right? So often that is the hard part, where you have to actually run the meetings, talk to people around the world with very, very different implementation scenarios, find out what they can do, help them get there, and then test it, see if the thing can actually hold water, to use a bad pun for an ocean presentation. This is important for IOC and UNESCO because there are forces working against us. Global multilateralism is weakening. We see this geopolitically, but this also is affecting our data networks. There is a lot of desire that's growing among governments, but also among scientific federations, also among corporate federations, for sovereignty over their data, technical sovereignty or technological sovereignty. We see the whole semiconductor issue, and increasingly data sovereignty. And of course, new regulatory frameworks are coming into play, new competitive frameworks, when people realize the value of controlling data. I mean, some of the big tech companies got in early, so there were no regulations, but now they're coming. It's going to hit us too in earth science. So all of these forces are contributing to the cyber balkanization or splintering of the internet, which is really, it's already happening. It's we see major blocks in the world with their own internets. The idea of the web as a unified system is not there anymore. So we're working against that, and we have to find out how people can tunnel through the various walls that are being created in a way that they're comfortable with, that's legally compliant, and that they can share information. So that's what we're trying to do within the UN Ocean Decade. Before the decade started, back in 2018, 2019, the implementation plan was published with a data section that emphasized linked open data for that very reason, because people need to be independent. Like, the systems we cannot pretend we'll have one single system for the ocean. They need to be independent systems being able to interoperate. Okay, great. So since then, we've been developing documents like the Decade Data and Information Strategy, and we're currently working on the implementation plan associated with that strategy to give concrete advice to all of the member states, the UN member states, and other stakeholders who want to share data in the system, to what they should actually do. That's the lower level recommendations, and many of those that you've just heard here will be folded into that a little bit more generically, because we can't be prescriptive, but very much that logic and thinking. So we're working on that now. We'll be publishing drafts on GitHub. You can post issues on that over there. It's an international team. We tried to get representation from all of the regions and ocean regions in particular. Myself and Kevin O'Brien from GOOSE, so the Global Ocean Observing System, we're co-chairing that at the moment. So that'll come out. So we take a step back to 1955, because something very special happened there in the ocean world that affects all of us today. This chap, Malcolm McLean, he sort of led a little revolution that took the old sort of shipping from longshoremen loading things into boats to the intermodal shipping container. That revolution, that completely changed the world. It was one of the biggest revolutions in human technology. And in a sense, that's what we're charged with replicating with things like Otis, things like CDIF, and agreements built around SOSO and others that inspired the Otis work. So his fundamental insight was that, look, shipping is not about sailing ships. It's moving cargo of some kind, people, produce, whatever. And we shouldn't really care what that is. If you can crack that, we've done something very interesting. And in a sense, we picked that up in our software world, right? So, things like Docker, it's not about trying to reinstall people's operating systems or sailing your operating system. It's about moving your functions and your programs. The same is true for data. And we need to think about how that does. So Otis and OIH are trying to create these digital supply trains following that logic so that the world can actually trade over data a little bit more effectively. That's our aim. You've probably heard aims like this very frequently, but what's interesting is that this kind of language that has been in ESIP for a while in our techie circles, we've now gotten this into UN documents at a high level towards the General Assembly and the member states, and it has been adopted. Actually, recently, Otis, as it's no longer a project, it's now a sub-program underneath the Intergovernmental Oceanographic Commission's data wing. So it's actually reconfigured a little bit of the UN system. So that's good news for us data folks, because the world is listening. We started in these implementation regions for a reason, because we could not leave people behind. We had to work with the small island developing states, stakeholders in Africa and Latin America and the Caribbean, Our funder requested that, the government of Flanders, Kingdom of Belgium, in order that people don't run off with fancy technology that other people cannot implement. We had to make sure that you could hire a contractor in any one of these countries and plug in a local system so that you could represent the world. And it's working. Very much along the lines that Steve and Doug mentioned, JSON-LD, schema.org, metadata shell, and a lot of stakeholders all over the world are now plugged in and sharing, and we can verify that they're sharing, we can verify that they're online. So when something goes wrong, we can detect it very rapidly and then help that partner reconnect. So again, you have to trust, what is this? Trust but verify, right? That's instrumental in terms of technological frameworks and the themes of this meeting. We have to verify that things are working, and then people will start trusting each other a little bit more. Handshakes don't do it. As the graphs grow, we can monitor them and we can see how that goes. And this will be the foundation of some reports for the UN about the state of ocean data eventually. So that's our goal. So you've seen it, our core profiles, the things that are being used to share information about people, vessels, training opportunities, maps, projects, etc. Just like you've seen, it's JSON-LD schema.org. We chose that because of its market share, if it's adoption, and the fact that it's cross-indexed by other networks. And again, in any one of those regions, you can hire a contractor that's probably worked to connect a business to Google, and they'll know how to do this. So there's that sort of pragmatism that needs to be put in there. So that essentially is our generic container for shipping content. Now, it's just the metadata level for now, but once we have that anchor, we can start to deepen interoperability. And even at this very moment, you can, of course, inject things like ontology terms as defined terms into things like keywords, or you can add inside a variable measure block, which Science on Schema have been working on for quite a long time. You can embed other semantics into the schema.org shell. And that's really instrumental to letting this thing grow and letting pluralism flourish, because you cannot force the world to agree, but you can nudge them there, certainly. So it's operational. You can search across that. All of our federated partners are putting stuff into this commons. And you can do queries that you were never able to do before, like seeing who has data in a certain region about whales, for example. There's more transparency than there has been thus far in the IOC context, at least. The UK's plugged in some of those data nodes. They've really figured it out and they've gone whole hog. So when you put down the wealth of data that they're putting up there, there's a lot more, a lot of spatial footprints. We have to update our user interface because people are sharing data like crazy, and new science opportunities are arising, but also better policy making, better decision making, and public information. Right, so we have a giant distributed data lake, and things like that discovery layer, it's an index. It's a federated index that all of these partners are building, and it's the first step towards, let's say, a little bit more structured part of the internet for the oceans. Eventually, we want that to move towards more data space logic, but that's going to be a bit of a journey. But CDIF is an instrumental part of that. And being part of WorldFair, we did an assessment across the other domains that Arifan mentioned, and sort of came up with the priority areas of where we need to interoperate. I won't go into details here. Again, it's in the report. You can get that from Zenodo, that deliverable from WorldFair. But that's the key. Understanding that the priority area here, if we want to scale what we did in Otis, we'll need to align to something like CDIF. Now, this is becoming quite easy because Otis was never built to be ocean specific. It was just schema.org JSON-LD. Of course, the content is ocean specific, but not the casing. So that's cool. So we have the next deliverable, 11.2, where we described how we do that. And again, not going into details, but essentially, we're pushing what we figured out in Otis based on Science on Schema and refined through our global partners, using the resources from WorldFair at the time, and putting it into the draft of CDIF to say, can we use this as a discovery layer so Steve and others can work on that? So we basically just pushed it out of GitHub, created a GitHub organization for CDIF, created a little repository for this core, and it's just in a pull request right now where we're figuring out how to actually take it apart and then go through a maturation process. And that's key. That's where the governance structures come in. See if the other domains agree, the other experts, and then broaden that out to see if it's actually going to bring things together with things like Sky, I see you in the audience, the USGS graphs, or Polder, or Decoder. That is the key. If CDIF can help us bridge, then we're in business. So that's the idea. Once it's in there, then other domains can fork it, of course, keep that core interoperability, and of course, create their own specific extensions, but within the same framework, so that if you strip all the domain-specific extensions away, the basic stuff still works. And that's really important because you cannot assume anyone is ever going to know about your domain extensions. So that's it. When those things mature, they can push it back into CDIF if they think that they can modify the core in a way that suits everybody. And it can be, again, a communal effort to upgrade the core. So great, we have the tech foundation. We've shown through Otis and others, and other projects have shown that this works, you know? What do we do? So the ethical question is, we have the capability, so we're almost obliged to do something about it. We need to bring these graphs together, but that means we need stable governance structures, and that means we need a little bit of help understanding how to run that. Technically sound standard operating procedures, but also in terms of handling the people and the ideas, and then always testing it against functionality. If we work together and things work out, then trust gets built. How this is all controlled is key. As Arifan mentioned, it's not just science, right? We have the corporate data group, we have governments, we have a whole bunch of different interest groups involved. And then, of course, as was mentioned in the keynote, indigenous data, for example, the policy around the care principles, that is being factored into Otis, but how do we factor that in and how do we balance that? And it's key not to leave anyone behind in this process. So if we don't do this, then you know, we're a bit in trouble, because this is what we're all aiming at, and we have to bring it together. So can CDIF then be the Rosetta Stone for Otis to map to the others? Some initial thoughts. These are all negotiable, but I would say if the governance is stable and the representation of interests is meaningful, meaning that if I can go back to my steering committee on Otis and you know, with the member states and the regions and say, yes, this is a sensible recommendation for you, then that will work. It has to be working for something. So really clear competency questions, competency tests are set up, and there's a continuous integration thing running to make sure that the system is not just you know, nice on paper, but is working for people. When we change things in CDIF, everything shouldn't break for its federated systems if it's working. So again, we have to figure out how to balance all of those things, which means keeping innovation in a box and operations in another box, and letting a very defined process to let one communicate with the other. It can't be too high overhead, otherwise people will not adopt it. As Doug has said, you know, adoption is key, but it needs to work for people right away, and it needs to be simple enough to implement in a step-by-step way. And of course, it can't be idiosyncratic. It can't be an idiosyncratic interpretation of standard web approaches. Of course, the goes without saying, technical quality has to be high, and multiple independent parties from different domains have to validate that everything's going. So these are the things I'm putting on the table in terms of how to converge. These are guiding thoughts. It sounds a bit harsh, but at the same time, that's what it's going to take to convince things, because it is our moment. It's time for us to build this intermodal container for our data and metadata. So that's it. Over back to you, Steve.
All right, thanks, Pierre. Lots to unpack there, and I think the big challenge is, okay, so how do we do this, right? Because I mean, what's needed, at least as I understand from what you're saying, and I think, you know, I'm in agreement, is some kind of stewardship framework. And I know ESIP has a good track record in that respect, but we need to bring in a broader spectrum of stakeholders, I think, into this engagement. You know, Pierre, you're working in a lot of UN realms that I don't think are very much engaged right now in ESIP.
But they
So,
wouldn't be, I mean, they wouldn't be engaged in ESIP. They have, again, their own level of operation. But at the same time,
right.
we don't want a UN style governance strategy for something like this, because it's glacial, right? It's very effective. There's a reason it's like that, so that more wars don't break out, right? But we don't need something quite so heavy here. So I think that's the sweet spot. ESIP has things, but my feeling is that they're mostly ad hoc, right? I mean, this is getting to the stage where we would need sort of professional guidance on how to run or how to govern this thing, you know? Some sort of consultancy about how decision-making should be done, etc. Because, I don't know, Arifan, are you still here?
Yeah, he's
okay. So,
yeah.
So from co-data side, I don't know if you've come across something effective there.
Well, I think it depends a lot, Pierluigi. The slide you presented, sort of saying these are the things we have to be serious about, I absolutely agree with. I am not convinced that we have answers to all of those questions now. The place I tend to look for this kind of thing is in in the way that standards are maintained, with large scale standards in a lot of other industries, in some IT areas. But I think there's more on the table here potentially than there has been in the past for things like more limited technical standards. So that's probably not a sufficient set of examples to go by. I think within the international organizations, there are examples of how this can be done. But like with the UN, I think they move very slowly and deliberately. And I think there's probably not with the flexibility that we have. I'm not, I couldn't say with a straight face that I think we have the answers from the code data perspective, but I think we agree on the need here.
Mhm.
The challenge right now is to get this thing to the point where it's adoptable and implementable. Following that, I think we have to get a lot more serious about what the governance is, how we run the operations. And I think those are good points that we haven't necessarily engaged with fully at this time. That's
Yeah.
not a very satisfying answer, but I think it's an honest one.
I mean, I think we're all there, really. How do we actually do this? Because I think about, like, Sky mentioned the graphs that they're using in USGS. Doug and our Otis team, we're building interoperability with WMO, with UN Environment, with other metadata systems. And it's easy enough because I think what all of these things have in common, it's choosing the right spot, the metadata layer first. If you can do that, you have a kind of anchor, and then you can negotiate deeper data interoperability, API calls, etc. But that's already really hard because once people have systems and funding, they're entrenched, right? But if CDIF, so I mean, for me, this data space thing is the key, right? So a data space, if you go to something and say, look, I need data in this serialization with these semantics, can you give it to me? If CDIF can provide the translation tables, basically, like the semantic mappings that semantic harmonization is working on, and these sort of serialization conversions, DCAT to schema, that's where all of these systems can look at to find the data space logic that's co-governed by the right people in order to do the conversions. Then that's what's missing, or it's fractionated, and it's really sort of haphazard right now, at least from what I see.
I guess I would add to that, Pierre, that there is a lot of energy going into discussions around what that kind of a framework looks like and how to govern it. And I think FAIR gives us a sort of global, I don't even know how to just describe it, but there's a conversation going on globally now that wasn't happening 10 years ago that I think opens some possibilities for us. I'm not convinced that we have identified the correct solutions, but I do think that there are a lot of people interested in having that discussion now who wouldn't have been a few years ago. So I guess I'm not, like you say, I think we've gotten the attention of people who didn't used to care a lot, in some of these issues. So there's work to be done, but I think we have a way forward at least.
I mean, in that framework, really the stewardship of those mappings is kind of the critical a critical component. And who does that? But on the other hand, Pierre, I think to me, looking at how things have gone over the years, is that one of the critical things that drives adoption is if people see something working, right? And to me, that's the attraction of what we're seeing with the ocean data system and some of the work we've done with Otis, and there's probably other systems out there, is really if you can say, look, people are doing this and it's working, let's document how that's working so other people can do it, would be a good way to promote adoption. It's like Sky, go ahead.
Yeah, hey, thanks for putting this together. I mean, I think it's a very timely conversation we need to have. And as I said in the last session, I didn't put myself on camera because I didn't take a shower this morning, so I apologize. But yeah, no, I think, Pierre, you said something really key there a minute ago, that sort of once an organization, institution has the funding and everything established and kind of gets their stuff set, it's really hard to change it and move that along. I mean, it was clear back in like 2011 or 12 or so, as schema.org was just starting to come online, and I was still involved in building ScienceBase at the time, that we were one of the first ones to put schema.org metadata into our ScienceBase pages. I mean, this predated getting, JSON LD and all the other stuff that's come along in the last, 10 years really in place. But we did this kind of basic thing to start getting stuff out there. And we, immediately saw search engine optimization results and other things from that. But then we just sort of stalled there, and we essentially have two assets from the USGS that are sharing basic structured data, science-based in our publications warehouse, and both of them are completely broken right now because that functionality is not in the critical path of our organization. It is not what we are being held accountable to, and it's not where we have any sort of a forcing factor to say, hey, we need to kind of get our act together here, in some way. There's essentially nothing right now that is screaming at the USGS loud enough as an institution to say, you guys need to do a better job with how you're exposing all of these assets because nobody else can find them. We all know it's a problem. We all know there's an issue there. We have the underlying information, we have the underlying content, and we have the capability, even in the technologies that we're using, to implement exactly what we're talking about here. And there's some really cool lightweight things like using, HTTP, what Doug was talking about there, that might open the ball even more for that. But what we have to do is get to the point where there's kind of, at least for an institution like ours, that's kind of already doing a bunch of this stuff, we have to get it to the point where there's enough, loud messaging coming from important stakeholders to say, you got to fix this problem of not really exposing your stuff for the rest of the world to look at. And I'm trying to engineer that right now, and I think I've kind of done that. I've proven what can be done if we really pull all of this stuff together into one place, in terms of new functionality for asking questions of our institution. I've screamed about that loud enough, and I have leadership involved, and they're excited about it, and they want to make change. Now I have to get all of the technical parties across like 8 different systems to actually get in and implement the stuff in the right way. Fortunately, the technology, like you said, Steve, we have something that works. We have a process that works. It's been proven. It's not that hard to achieve. So if I can get all those parties to the table, I think we can actually make progress and move that ahead. But it kind of takes putting all those different ingredients together to get an existing entrenched organization moving where it needs to go. And we have a lot more flexibility on a new startup, on something that's actually just getting started, and we need to go after those as well.
Yeah, I'd completely agree with that, because for us in Otis, we had those ingredients because of the UN Ocean Decade. There was a global call from the member states to their scientific organizations, their businesses, etc., to do something for the ocean. Part of that was data. So over here in Germany, we have our local politicians asking the directors of our scientific institutions, what are you doing for the Ocean Decade? And then I can say, well, it's really trivial almost. If you have a good IT team, it's almost trivial in a country like Germany to connect up to Otis. And that's on paper. You can get all your certifications and all of that. Is a decade contribution. So I think you're right. And maybe that's again where CDIF and CODATA, because CODATA is the data branch of the International Science Council. So if they can issue, once we get this sorted out enough and clear enough, the CDIF principles, etc., a little bit tighter, if we can issue a call at that level, maybe a joint call with UNESCO or something, and then that's something that, again, can be put on the table of the decision makers and say, all right, this is high visibility enough for us to say, let it be so. Because once they do that, if you have a good tech team, this is not difficult stuff. And now that we've tried this with so many different stakeholders around the world, everyone running like a fully fledged data system to those with a single web page, it's doable, right? It's doable to do it without messing up what you're doing already. And I think that was key. When we started Otis, we had people coming over saying, well, you're going to use this technology, right? And I said, it doesn't matter. It's technology agnostic. You can keep running your system the way you'd like to. It's just this data export. So decoupling the tech and the data also relieved a lot of tension in that negotiation.
But Skye, in your context, is the issue trying to bring managers some tangible indication of the benefit, to the organization from doing this activity? Is that the problem?
Yeah, I mean, really, this kind of stuff comes down to the need for interoperability and integration beyond ourselves. I mean, we as an institution are kind of doing the bare minimum that we've needed to do to get our stuff out. And, it's not that even that's all that new for us. We've been doing that for a long time. USGS has published data and everything openly and all of that for well over a century. You know, so we got a good history of doing that. And unfortunately, we're kind of resting on our laurels to some extent in that. And even through the last number of years, as we've pushed open data policies and we've gotten our catalogs together and all of that kind of stuff, we have put more and more and more out there. But the problem to a great extent is that, you know, that stuff it's just more stuff. it's more stuff online, and we've done the bare minimum of getting it onto websites and into catalogs, and there's, you know, custom bespoke APIs that you can use to interact with those things and all of that kind of stuff. But, you know, there's not really the massive driver that's saying, you know, well, you actually need to, you know, deal with all the issues that come up with having tons of duplicates, and you need to deal with all of the issues that come up when you try to put this data set together with this data set over there, that are really going to force us to change a bunch of the underlying mechanics of how we're managing this content and how we're exposing it to the rest of the world. And, you know, so, I mean, that's where we've had to kind of really push on what the use cases are that need to drive enough of a requirement for change, that we can actually bring these system owners together and say, you know, hey, you guys are doing the website, you need to do this thing over in your Drupal CMS, and you guys that are doing the, you know, science data catalog, you need to do this kind of stuff in your JSON LD in order to improve it. You know, kind of putting all of those pieces together, it needs that big interoperability integration driver to really push it ahead. And yeah, I mean, absolutely, we have things like the Geospatial Data Act, we have the Nelson Memo, we have these things that are pushing us to do better. We get that, you know, but it's still there's another hurdle to get over to actually get major action that needs to happen within those systems. But I think we're getting there. And one of the things I proposed and need to come back to in Slack is I want to try to do sort of a state of linked open data using the methodology that you guys are talking about here today, leveraging Gleaner and some of the stuff that's been done with Otis to really look across, you know, in the US at least, our major Earth observation agencies, NASA, NOAA, and USGS, and say, you know, how are we doing?
Right.
You know, what can we hit in terms of sitemaps, in terms of, you know, linked data in pages, other ways of trying to put all of this together, and knowing that initially we're going to create some giant morass, but that's actually useful. And being able to say, okay, these guys are doing this over here, and this is what they're able to expose, versus us over here, this is what we're able to expose. I think that'll develop some interagency peer pressure that will help to seal the deal and move the thing along.
I think that will happen. I mean, we saw that happening as Otis started its operational phase. People were started to come to us, like member state representatives, National Oceanographic Data Centers, when a memo was sent out. They had a willingness to do that because they saw their peers connecting and also getting value out of it, right? So in the Pacific, for example, they can see who's gathering data around their island, and they were never informed about that. And I really like that idea, Sky, about some sort of state of linked open data in general. Again, I was asked some years ago by the executive secretary of IOC to write a state of ocean data report. And I said, no, I can't do this. I mean, I can't do this in a month because what am I going to do? But now that we have Otis, I could say, all right, this is not exhaustive, but at least we have a kind of radar of the state of data, you know, the metadata, warts and all, you know, it's all there. And if we can do that generically across like the USGS graphs, Polder, and geocodes and all of that, that would be really, I think, a call to action. Again, that ethical consideration that we are so close. If we can push this a little bit, it would be quite strong. I think maybe even Arafan from the co-data side, with the theme of this meeting, talking about data ethics, it's not just about what you shouldn't do with data, it's what you should do given what you have right now. And I think maybe a co-data call for this would be quite cool.
That's an interesting idea, Pierre. I feel like that a big part of what co-data does is on the data policy side. We have a lot of connections with UNESCO around open science and sort of function as well on that level on behalf of the ISC. I think some of the pressure that needs to be brought to bear isn't about the technology at all. It's actually about creating the pressure to do some of these things. And I think it's worth thinking about. I mean, that's something we could discuss with Simon for sure. You know, I think there's a lot here to work from. But again, I think there's There's still work to be done getting the technical stuff in position. I think we're almost there with that. I think it's easier to make the political case when there's more to point at, when there's more solidity to it. And so it may be a little early days at the level of code data, but maybe not. You know, I think we have to start with from where we are.
So,
We have
and interestingly, I think the question about the, are we there technically yet? I mean, in this group, do people see any technical gaps in these frameworks at this point? I mean, where are there holes that we need to focus on? I've seen, we have a lot of, I think Sky was talking about, there's a lot of sort of top-down directives, the Stewart Act and things like that. But the other end is really this bottom-up stuff of, okay, what are people actually using? Do we need to think about building into these frameworks more ability to collect analytics about what's actually being used?
Yeah, I think like for us to notice the dashboard bit was very important because again, a policymaker or decision maker in terms of a manager position, they want to know that kind of status report. So for that internally, it works just saying, okay, we have this many nodes, they're using these kinds of types and schema, right? So that sort of status report. If that can be generalized across, certainly not just within that scenario, that would give us that report, I think. Again, but we're always in this sort of passive mode at the same time. I find coming from like a research background or so that we like to study things and give status reports. But what I've learned also from the Otis experience is that if you change things while doing this, you're basically gathering intelligence and using that almost right away to implement something significant or to change something significant. It has far more impact. I mean, we'll see something in our lifetimes, which would be nice, right? Because it's nice to see the sort of like fruits of one's labor. So I think it's a combination of both. We see that now. So for example, if this took some convincing to say, let's move Otis into CDIF, right? Because again, that's a different governance structure that's out of the hands of IOC. Now, why would they agree to that? Because they see the potential benefit. Again, it's not a done deal yet. And that's why it's at that stage. If we can have a handshake between something like Otis and then another graph system like that, that's a very meaningful thing.
Mm-hmm.
I think, Steve, that there's a gap between what we know we're capable of doing with the technology and the practice on the ground. And this gets back to some of the things that Sky was talking about. I mean, when I looked at the Copernicus data in a project recently, what they had for geography was horrifying and way less than what I would have expected from that high visibility data set. We were using the ERI5 data. And so I sort of feel like that Pierre has talked a little bit about getting sort of real time. You really have to look at what's out there and measure what's out there and make sure that things continue to work. And to get that kind of a landscape view and that kind of an ongoing assessment, I think is actually really important in building the kind of trust you need. I don't think this is an easy task, but I think that we have to get a little more serious about it in that way. I think Otis is one of the examples that I look to out of all of the domains that we work with, because I feel like they've got a pretty good approach to doing that, and in a way that's pretty compelling. And I don't think that's true in a lot of other domains. So, but I do feel like getting that sort of state of linked data picture would be a really important first step in bringing the reality closer to what we know we're capable of doing.
One of the things that allowed us to do that was the sort of neutrality of a UN system. Like they have no horse in the race per se. I've worked on European projects or other projects where in a sense, part of the job is to say, look how great we are, right? I mean, that's part of it because it is taxpayer money and you are achieving things. So you should certainly talk them up. The UN perspective about, look, we're here to really just give the status report and not emphasize, overemphasize or de-emphasize anything. So I think that's a lesson we can put into our governance frameworks, that this is not a sounding board to promote one idea or one implementation over another. It's just saying, okay, what is our best route towards more global interoperability now? How do we include the most people while being technically sound? And then branch off from there. Again, these sort of guiding principles are good. So Anne says we have a friendly time check, and then she shows up, which is
all right. So we're almost out of time. I guess I just, to sort of summarize here, I get what I'm hearing, I think is there's interest at least amongst some of us who've been speaking in trying to converge what's going on with CDIF and SOSO and Otis. There are some questions about what the stewardship would look like. We need more information about the landscape of linked data that we're talking about. And there's some issues, you know, just in terms of integrating CDIF and SOSO at this point, probably with Otis as well, that we can work on. And I think more conversation, probably at least in the ESIP context, would be appropriate in the scienceonschema.org work group to figure out how we can converge these things some more. Anybody else have any other closing ideas, statements? She's not smiling now. Do we have to go yet, Annie?
I only provide a friendly off ramp that if anyone that it is 3:30 Mountain Time, which means that the session is officially ramping down, but you are by no means kicked out. It's more like if anyone needs to go, they can, but the Zoom room is open if you all would like to keep chatting and thinking about next steps.
All righty. Well, I would point people, had some links in there. There's a cross-domain interoperability framework GitHub organization. We've had links in the presentations for our current draft. We're looking for feedback on that. And we'd really like to pursue more alignment and resolution of any differences between what we've got in the CDIF recommendations and SOSO and Otis. So if stay posted. Oh, good. Pierre put a link to the GitHub repo in there. And does anybody else have anything they'd like to add, please? All right, everyone. Well, thanks very much for participating. Good to see you all, and talk to you soon. All right.